a relatively infrequent disease is a huge, in my humble opinion, come on up. I love epidemiology. You want to help me with this?
Sure.
Okay. So testing for a relatively infrequent disease is a waste of resources. It's kind of like screening the average population for HIV. You know, we screen blood donors, and from that comes the concept of positive predictive value of a screening test, a dichotomous screening test, positive or negative. Positive predictive value answers the question, if I have a positive test, what is the likelihood that I really have that disease? Now, I wish I had an easel so we could do the 2x2 table, right? Positive predictive value is, if you look at, if I could draw the 2x2 table, you have one side is those with disease, one side without disease. And then the top row, you have positive tests, the top row, negative tests. Down in the bottom corner, you have the population that you're screening. Along the one side, you have all the positive tests, all the negative tests, and at the bottom, the total with disease and without disease, right? So, if we screen 1,000 cats that have, depending on what you read, anywhere to 1 to 3% prevalence of a disease in a population. Let's say 1 just for round numbers. If we screen 1,000 cats with 1% disease prevalence, how many cats in that population have disease? 10. So now, concept of sensitivity, the ability to correctly identify a disease, and specificity, the ability to correctly identify those without disease. Let's just say, again, for round numbers, our test is 90% in both those parameters. We detect 90% of those with disease and 90% without. Okay? Are you with me so far? Or am I good? All right, so now, 1,000 cats, 10 with disease, that means 990 don't have disease, right? So we detect 90% of both those populations. So we correctly identify 9 out of 10 cats that have this disease, and we correctly identify 90% of 990, 891, I think, because it would be 99. Now, there would be 99 false positives. Okay, so what we've done, we've correctly identified 9 out of 10 that have disease, and 891 out of 990 that don't have disease. Now, that means you have 108 total positive tests. Positive predictive value is true positives, those that have the disease that tested positive, over the sum of true positives and false positives, or all those that are positive, which is 108. So, 9 divided by 108, anybody got a calculator? I think it's like 8.3%. So basically what we're saying is, if we have a positive test on this population, there's an 8.3% likelihood that that animal really has that disease. So what are you going to do? You're going to euthanize based, I mean, that's pretty crummy odds. Would you like to explain anything better? Add anything?
No, you did a great job. So just, yeah, when it comes to screening, the two aspects of the test, the sensitivity and the specificity, those are actually properties of the test itself. So the sensitivity is ask the question, how well does the test actually pick up the disease that's there? So it's kind of like the way we use the word sensitive in the English language. How sensitive is the test to the presence of the disease that's there? And that's a property of the test itself. Same thing with specificity. How specific is the test to what we're looking for? So a high specificity means that it's only positive for what you're looking for, and it will be correctly negative for everything else. So when you have a rare disease, since so many more of the people or animals or whoever you're screening don't have the disease, the specificity actually turns out to be the more relevant number from the positive predictive value standpoint, because if you have, let's say you have 100% specificity, that would mean that everyone without the disease is correctly identified as not having the disease. So you don't have a single false positive in your thing. So everyone who tests positive really does have it. But the minute your specificity starts varying away from that 100%, you're going to start to have false positives. And even, so if you have a sensitivity of, perfect sensitivity, 100%, you always catch the disease there. And your specificity looks close to perfect, like 99.5%. Even just that little bit away from perfect can mean, if you have a rare disease, that many organisms, cats or people, become false positives, and they will really ruin your positive predictive value, because most of the animals who test positive now will be ones who don't have the disease. And the same thing happens actually, mammograms, ovarian cancer tests, the same thing happens with people, because it's so much more common to not have the disease than to have it. That little shift away from perfect specificity means that most people who test positive, or most cats in this case, aren't even going to have it.
So,
One other thing.
what's your name?
Oh, wait a minute, yeah. We have a prize for
She's hired.
Whatever she said, she's hired.
I don't know what she said, but she's hired.
The other thing that affects positive predictive value is the prevalence of disease in the population, which is why I mentioned the low prevalence diseases. You know, you're not going to have that many true positives. So if we jump our prevalence up to 15%, like intact males that are fighting, then our positive predictive value in that same population, and I could do the math if I had a table, but it jumps to like 63%. So now you've got something potentially meaningful.
So, what is your name?
My name is Beverly Levine, and I'm actually a breast cancer epidemiologist at Wake Forest Medical School.
And it's up there. Wake Forest. I went to Chapel Hill. So I got my MPH. Okay.
Kind of sum that up for everyone, guys, and Dr. Newman. So you started off by saying when you test for a rare disease. So what does that have to do with FELV and FIV? Because, I mean, it's pretty prevalent, isn't it? No. What is it? How prevalent is it? Anyone? It's a very small percentage, 1 to 3%. There are some populations it's been as much as 5%. So when you test with this in-house IDEX SNAP combo test, many of you have worked in these clinics, you know about them, you've used them, and they're very sensitive because you have to take them out of the refrigerator and warm them up. And what we would do at the beginning of the clinic for 8 hours, we would take them out of the refrigerator and they'd sit there all day because we would rarely use them. And are they any good then at the end of the day when you...
They are. We left them out for a week.
You left them out of the refrigerator for a week? That's not recommended.
We've tested it now.
But that's not recommended. So that's my point, is that you can have even worse problem with them. So what's the upshot? So I think the takeaway here is that we're not testing, because when you use these in-house SNAP IDEX SNAP combo test kits that test for 2 different viruses, the feline leukemia and the feline immune deficiency virus, that it's not a diagnosis.
It's a test result.
It's a test result. So did you get that? It's not a diagnosis. So I hear people saying, we've got to diagnose FELV and FIV in these cats. You're not going to do that with this.
Well, and to expand on that, one of Weedon's laws is a wrong answer is worse than no answer at all. If you have a wrong answer, you go down that road and you're not even going to continue to look. If you don't know, you can continue to look. And with an 8.3% positive predictive value in a low prevalence condition, and that means you have 108 positive cats. If your outcome is to euthanize those positive cats, you know, only 8.3% of those cats that you euthanize really have the disease. So, you know, the other, what, 91.7% got dead for a wrong answer.
I'd like to add, the only ones that we actually do testing on are the ones that we're pulling out of the environment. So the kittens. We just brought a number of cats back from Tangier in June, and 2 were kittens, and they were positive for FIV on the SNAP test. Well, when that happens, we hang on to them, and after a few months, retest, and they were negative. So those were definitely false positives at that point, and there's a number of reasons that that can occur, but I think that, again, it just leads to ambiguity and makes testing really not very, it's just not a good idea, I think, for the general population. It's not going to help you make decisions on what to do with that cat.
Okay, so I cannot believe this, that we've had so much fun, that it's almost time to go.